Right, so first thing we're going to talk about is the product rule. So we're just recalling the product rule. If we have same bases, we're multiplying, then we add our exponents. So we just finished a unit about exponents, just had a little test over that and all that jazz. But now we're going to actually put some of that into practice while we're using other operations. So I'm going to zoom a little bit on number 1. And you'll notice I tried on this foldable to give you some worked out examples that I did so that if something happens and you just don't understand or your notes are hard to see because these are really tiny boxes. Okay, on number 1, this is kind of a review. If you have something on the outside of a parentheses, then that means to multiply. So we have to distribute that through. And I typically draw the little arcs. I don't know. I like to call them rainbows. So I like to draw little rainbows to remind me I have to distribute to both. So this says h times h. So that would be h squared because this has an exponent of 1 and this has an exponent of 1, and you would add those exponents. Then you would have h times positive 4 would be plus 4h. So even though the h comes first, we don't write it h4. That's just not how we write stuff in math. So the number always comes first. And that's the final answer on that. So not terrible. Then we're going to skip to number 5. Number 5.
Oh, H4? Or I don't think they're wrong. H4.
4h. So when you multiply, it looks like you would write h4, but we always put the number in front because that's the coefficient. So on number 5, we're going to also need to distribute. So 3c times negative 2c would be negative 6c squared. So we multiply the coefficients, and 3 times negative 2 is negative 6, and then we multiply the variables, and c times c is c squared. But we're not finished because now we have to distribute negative 3c times negative 5 would be negative 15c. And that's our final answer. Okay, so that is a monomial times a binomial. We are now going to look at number 7, and you'll notice this monomial is multiplying by a trinomial. So we have 3 terms we're going to distribute through. So I'm going to go ahead and draw my little rainbows. So I have x times x squared would be x cubed. Then x times negative x would be negative x squared. And then x times positive 3 is positive 3x. Very good. And that's our final answer. So we'll go to number 8 right next to that. This time it has a coefficient and a variable, and you'll notice our exponents are going to get a little higher this time. So we draw our rainbows to remind us. 5m squared times 3m squared. So 5 times 3 is 15. And then m squared times m squared is m to the 4. Then we're going to do 5m squared times negative m. So you could think of this like a negative 1. 5 times negative 1 would be negative 5. M squared times m would be m to the 3rd, or m cubed. Then we look at our last little rainbow, 5m squared times negative 7. So 5 times negative 7 is negative 35. M squared, there's no variable here, so it's just m squared. And that's our final answer. So directly below that, number 11. So we're going to distribute 3xy to everything. So we're going to notice that there's no number in front of x squared, so it's kind of like a 1. So 3 times 1 is 3. I have xy times x squared. So this x has an exponent of 1. So how many
X cubed.
x cubed? Good job. And then I have to still have the y there. X cubed y. Then I'm going to go to the second here. 3xy times positive 1xy. So 3 times 1 is positive 3. X and x would make x squared. Y and y makes y squared. And then we're going to look at the last one, 3xy times positive 1y squared. So 3 times 1 is positive 3. X, and there's nothing over there, so it's just an x. And then y times y squared is y to the third. Can we combine all these together? Like add them all up?
Yes.
So how do we know if we can add something or not? Has to have exact like terms. So I agree, all of these have x's and y's, but are they exactly alike with the exponents and everything?
That's what I asked her to do.
So this is our final answer. We can't add them together because they're not like terms. That's something that's confusing to people. Last one we're going to do is number 14. And we're going to distribute. This is a monomial times a binomial, which is actually a little bit easier. But what's hard about it is it's got all these exponents. So first, I look at negative 4 times positive 9 is going to be negative 36. I look at my same bases. C to the 3 times c squared would be c to the 5. Then I look at same bases. D squared times D squared is D to the 4th. Now I'm going to look at my next little rainbow here. Negative 4 times negative 4 is positive 16. 4 times 4. And then C, I have C's in both, so I'm going to do same bases. C to the 3 times C to the 1 would be C to the 4. D squared times D to the 5 would be D to the 7. Can I combine those together? No, because they are not like terms. So now on the foldable, mine looks a little different because it's like the folded out version. So we're going to start on this top left flap that says FOIL. FOIL is an acronym that means first, outside, inside, last. And that acronym just helps us to make sure we distribute appropriately. So we're going to start with this tab, and when we open that tab, it's going to look like this. And guess what is right here? The same thing. So this time I want you to fill in the blanks. So F means O is, I is, and L is. And then I put this little star at the end. We have to combine like terms. And so we're going to start with our first example is going to have letters instead of numbers, which is a little bit weird. But it'll help you kind of see. This is different than what we just did because this is a binomial times a binomial. The one we just did was a monomial, one thing that we distributed through. So basically we're going to do this like we're going to distribute the first term through everything, and then we're going to distribute the back term through everything. And so it's called first, outside, inside, last because we literally do the first thing times the first thing. So A times A would make A squared. Then the outside one, so A times negative b would be negative ab. Then we do the inside ones. B, positive b, times positive a would be positive ab. Why did I flip the letters? Because alphabetical order. Then we do positive b times negative b is going to be negative b squared. So that is FOIL, what we just did. But that's not our final answer because, like I said on the star, at the end we have to combine like terms. So typically these two middle terms will be alike because the letters are exactly the same with the same exponent. So a squared has nothing to go with it. Negative AB, so it'd be like negative 1AB plus 1AB would cancel each other out, so we don't write anything for that term. Minus B squared. And that would be our final answer in this case. And that was your first time doing FOIL, and you guys did good. Not terrible? So we're going to do another example of FOIL right underneath. So using FOIL example right underneath. So we're going to start on this inside one, the 4x minus 3, because I wrote some of the steps out for us. So I gave us a binomial times a binomial, and then I drew the arrows for you. So I know it seems kind of silly to draw arrows and stuff, but these arrows help keep you on track. And so you could draw them as you go, or you could draw them at the beginning and make sure that you're doing all 4 steps. So this would be negative 4x times 2x would be negative 8x squared. Then we would do negative 4x times negative 7 would be positive 28x. So that was first and outside. Now we're going to go inside times inside. So negative 3 times 2x is negative 6x. And then last times last, negative 3 times negative 7 is positive 21. That's not our final answer because we can combine some like terms here. So it would be negative 8x squared plus 22x plus 21. That is our final answer. All right, so now we have another example we're going to try together, this one on this tab. So it's a binomial times a binomial, so we're going to start with drawing our little helpful reminders. 2x times 3x would be squared. Good. 2x times negative 4, so sometimes the negative signs get us, so 2 times a negative, positive 2 times a negative 4 would be negative 8x. Then positive 2 times positive 3x would be positive 6x. And then positive 2 times negative 4 is negative 8. We're not finished because we have to combine like terms if there's any. So we would have 6x squared minus 2x minus 8. And that is our final answer. So FOIL is probably what I would say the old school way of doing a binomial times a binomial. It's the way I learned when I was in school. It's probably the way most of your parents learned when they were in school. And then I was doing some research and I found this other method. And so I think it's a good method for some people. And then at the end of the day, you get to choose which method you like and whichever method you want to use. Okay, so the other method is called the box method. And so typically my students like this first, and then after a little bit of time goes by, they switch over and like FOIL better. Okay, so we'll see what you guys think.
I like FOIL.
Box method, draw boxes according to the polynomials. So what that means is, like in this example, it's a binomial times a binomial. So you draw 2 by 2. So it's like however many terms by however many terms. So 2 by 2. Fill in the numbers above the boxes. So what that means is we would do like this is C plus D, so I would put C plus D. And then the second binomial would be C minus D. And then at this point, we're going to multiply like each column and each row. So, and you guys have seen some of this before, and this is why for some of my students in the past, this felt really comfortable for them because they've seen it this way before. And then over time, they get tired of drawing the boxes and whatever, and they just go my way FOIL. Okay, but here we go. C times C is C squared. C times positive D is positive CD. Then we would do C times negative D, or negative D times C would be negative CD because alphabetical order. And then negative D times positive D would be negative D squared. It doesn't matter actually, so good call. You could do it either way. You could do the C plus D on top and C minus D on the side, and it would give you the same thing. So now we're going to combine like terms, and so you'll notice that I don't have any other C squareds, so I write C squared. But typically this diagonal right here will be like terms, and positive CD minus CD, these actually cancel out in this example. And then I'd be left with minus D squared. And really, if you think about it, this is the exact same example as I did on the first FOIL example. I just used different letters instead of A and B. So that is how you would use the box method.
In science or the tree?
Yes, the, what is it called, Punnett square or something like that? Yep, very much. And so that's, again, why it kind of seems familiar. And then, okay, so let's just start on the inside one first. This one, I gave you a monomial times a trinomial. So this is kind of like that first notes paper that we did today. So if we did it the way we did in our first notes, I like drew the rainbows and we multiplied. But this time I did a 1 by 3. But could I have done a 3 by 1? I guess, yeah. Okay. So we would do 4x squared times 5x squared, and that would give us 20x to the 4. Then 4x squared plus 2x squared would be 8x to the third, or cubed. And then 4x squared times negative 7 would be negative 28x squared. And so this is just another way of seeing our final answer. We can't combine any of these terms, so it would be 20x to the 4 plus 8x cubed minus 28x squared. So here's my one word of caution if you go with the box method. You have to remember if there's not a sign, that means it's positive, and you have to remember to put that plus sign right there. So we'll do the box method with actual binomial times binomial. So I drew the boxes for us. Which way do you guys want to write them? Do you want to go down and then across? So 2x plus 2 down the side. So we go 2x plus 2. And then 3x minus 4. So 3x times 2x is 6x squared. You can actually go any order you want to, like as far as which box you multiply next, but 3x times positive 2 is positive 6x. Negative 4 times 2x is negative 8x. Negative 4, positive 2 is negative 8. So then we look for like terms, which typically the diagonals here should be like, not always, but typically. And then we would have 6x squared minus 2x minus 8. And if you look on this foldable, this is the exact problem that we did with the FOIL. We just did it with the box method. And so it's really up to you which method you like best.